For those of you who don't know me, my name is Joseph Kenny, and I'm a PhD student supervised by Professor Daniela Mitterberger. And I'm here to talk to you about COMPAS XR. For those of you who don't know what COMPAS XR is an open source library that aims to streamline extended reality workflows to ease the implementation of human-machine collaborative applications in architectural research and educational environments. Specifically, COMPAS XR is focused on easing the implementation of robotic assembly and digital fabrication processes, offering things like in-situ trajectory visualization and multi-user coordination. And secondly, it aims to provide augmented reality visualization for task construction and adaptation in human-robot collaborative assembly for in-situ fabrication scenarios. The key focus of COMPAS XR is transmitting information between multiple users and on-site decision-making through augmented reality applications to the CAD environment as a means of supporting collaborative assembly processes, human-robot assembly processes. The original COMPAS XR is designed around three main components. The first is a Python and CAD integration layer, which connects COMPAS-based project data to design and fabrication workflows. The second is a cloud service layer, which allows multiple clients to read and write shared project information. And the third, a user-facing application layer, mainly Unity-based mobile applications for XR visualization and interaction. The key point of this release is to establish the basic infrastructure for linking multiple devices to the same project state. COMPAS XR has served as a base or been used in a huge variety of projects to different degrees, including both robotic and non-robotic assembly workflows, and all of which are focused on in-situ fabrication processes. While COMPAS XR has seen success and been utilized within a large variety of projects to support a variety of different use cases, generally XR development is difficult as it's situated in various operating systems, devices, interaction modalities, and platforms. To further facilitate this, we present COMPAS XR Sharp and COMPAS XR Sharp Unity. The specific goal of these is to ease development workflows for extended reality in AEC contexts and improve accessibility and customization for all end users developers. Specifically, we extended the software architecture by extracting the core components of the application layer into two libraries focused on communication, transformation, and serialization. These libraries are a C# generic library, COMPAS XR Sharp, and a Unity C# library, COMPAS XR Sharp Unity. The key components of COMPAS XR and COMPAS XR Sharp are to provide cross-platform support for things like COMPAS data structures, like the model, building plan, meshes, and solids, messaging and storage through infrastructures like MQTT, Firebase, and ROS, transformation across environments like Unity applications, Rhino Grasshopper, and Motive, and serialization through things like the COMPAS data interface, JSON support, and Google protocol buffers. Further, one of the core components of the library is focused on improving compatibility with industry libraries and standard operating systems. Additionally, it's designed to fit directly within the overall COMPAS ecosystem. And now, how to get it. COMPAS XR code is open source, as many people may know, and you can find it on GitHub. However, COMPAS XR Sharp and COMPAS XR Sharp Unity are coming soon to a repo near you. Further, as an example, I'll very quickly give you a short presentation on Pixelate. Pixelate is an independent research project that I developed in collaboration with Sam Bourgault, Professor Daniela Mitterberger, and a Populous Applied R&D group, in particular Sula Fabiras and Philippe Maman, out of Populous in New York City. Additionally, it was the first test case for the implementation and communication supported by COMPAS XR and COMPAS XR Sharp. The design of Pixelate was centered around public interactive displays. The big thing is public interactive displays typically exist in fixed locations and contexts. However, they are inherently multi-user. Additionally, they also serve as key places for community information sharing and collaboration. The big question with Pixelate is how can public interactive displays support distributed, cross-platform, multi-user collaboration while remaining tied to shared physical contexts? To explore this, we designed a collaborative system supported by cross-platform, multi-user interaction over a variety of contexts, devices, and locations, including Android, iOS, and web-based clients. This allowed users to interact from any phone, desktop interface, or head-mounted display, and expanded the collaboration format to include an interaction space that people could access through different devices at different locations, however they prefer. The interface itself is divided into 4 simple things: selection tools that enable users to select individual pixels and claim them, customization tools that enable users to define custom colors and attributes, review tools that enable users to review any previous state of the canvas, and erase tools that enable users to return any pixel back to its original state. While the tools were simple, they were designed around drawing to provide flexible user input. While users were interacting, they could see users' selections and supported from different drawing types. Further, these inputs were implemented through real-time through event-based data exchange. While your selections are depicted in white, other selections are depicted in gray. The goal of this project is to promote accessibility, collaboration, and multi-user interaction over a shared physical context. Additionally, for the remaining portion of the time, we'll run a small open-ended demo for people to interact, share, and explore. This will be run by my colleague and friend, Samuel Bourgault. Thank you, everyone.
Yeah, Joe's face in a tiny corner, but luckily we'll move to ETH in July, so we're lucky we'll have him here. Okay, let me just open this. So I invite you to take out your phones and scan the QR code. Oh, does that work? I know it's not working. Okay, well, it's missing. I guess it's a main component. I'll just go back to here. Oh, no, it's in the video.
Share and explore.
Yeah, here. Does that work? Okay, nice. Okay, let's go back. Oh, okay, people are starting to log in. So as Joe, wow, okay, I think the screen somehow is messing up, but at the top, over the color tools, you have selection tool, you have a drawing tool, a random tool, and keys, an arrows tool, and eraser, so you can erase your own or other people's pixels. And then underneath, a color, so select different colors. And when you're in this mode, to confirm your selection and your drawing, you click at the bottom on the, I guess I could probably, well, I cannot select the drawing tool, but you can submit with the green check mark. And then another feature that Joe implemented is over here in the user action. You can also go back to previous state. So if I click here, I can see that, I don't know which state that was, maybe the third one, but I can go back in time. And then if I uncheck, and you can do that too on your interface, I come back to the main state or the current state. That's it. Thank you for your interaction.